Hello Rangers, welcome back to the Snowflake GenAI series. In this particular video, we'll see what exactly is Cortex Search and how exactly you can use this Cortex Search. You can use this Cortex Search in two ways. One thing is you can build an enterprise search application, and the second way is you can build a RAG chatbot. How exactly this Cortex Search works is it follows a hybrid search approach. In this hybrid search, it consists of one is a vector search, the other one is a keyword search. In the vector search, it converts your unstructured data or your text data into vector dimension. Once it converts into your vector dimension, it will check how semantically your prompt or your query is closer to a particular document or a particular unstructured data. And the second way is with the help of keyword search. Whenever you enter a query or a prompt, it will search how exactly it is matching. It will match text to text and it will generate a score. So once you get your vector score and your keyword score, Snowflake re-ranks them and gives you the best results in a order. You can build this Cortex search in two ways. One way is with the help of the SQL and the other way is with the help of UI. So let's get started. So for this particular video, I'll be using a Airbnb dataset. In this particular dataset, I have various columns like descriptions, what is the price, what are the amenities, how is the room type, how many people it accommodate. This kind of a data is already available in this Airbnb dataset. To know how to load the dataset, just follow the links in the description. Before starting to create your Cortex search with the help of the SQL, I want you to understand some of the terminologies. So for example, I have a query. Show all the rentals close to the Sydney place and what exactly is cancellation policy. This becomes your query, and one of your column called cancellation policy is also being required by the user. So while building your Cortex search service, you should be exactly aware what exactly should be your search query, search column, and apart from that, what other columns would the customer need it. For example, in this particular query, the customer not only needs what are the places which are close to this particular rental, and he also needs what exactly is the cancellation policy. For example, there is another query. In this query, if you see, list that include DVD players or TVs and what is the price of it. If you see here, the user is searching for the amenities and also searching with the help of the price. So you need to understand your price can be a filter. So when we create this Cortex search with the help of the SQL, my search will be against this particular column. So my search query will be summary of the Airbnb, description of the Airbnb, and space of the Airbnb. And I have also included some other columns like price and cancellation policy, because for example, when a user comes, he is asking for me, apart from the amenities, he needs what exactly is the price. So I am indexing that so that user can find it whenever he search for that particular type of a query. I have declared my room type and amenities as a filter column. So these particular filters will help you to filter your results. So this particular warehouse will be used for indexing the data. In this particular thing, I am using an embedding model of Snowflake Architect Embed. For example, this particular Architect embedding model, if you see, it will be multilingual model. Okay, it can, and this output dimensions is around 1024. We'll see what exactly is this output dimensions. So let me create a Cortex search service. When you create a Cortex search service, it will take a little time because it need to index all your base data. Once your base data is been indexed and it's been converted into the vector dimension, the next time onwards, it will create a incremental refresh or incremental indexing or incremental vectorization. How exactly it works is, for whatever table you are creating a Cortex search, so for this particular Airbnb table, Snowflake would have enabled the change tracking. So let us check if the change tracking is enabled or not. If you see here, for the Cortex database, for the tutorial schema, for the table name Airbnb, change tracking has been enabled on. So let's jump into the Snow site and see how exactly our data has been converted into the vector format. So this is the Airbnb Cortex search which just now I have created for this particular tutorial. So there are around 5555 rows. These 5555 rows have been indexed and also been vectorized. So if you see the data, you will get the vectorized column. So this is the embeddings which Snowflake has created. So we have copied our embedding. let's check in how many dimension it has been created. So I'll jump to the Snowflake. So I'm finding the array size. So my particular listing text query, which is the concatenation of summary, description and space, has been converted into a vector dimension of 1024. Since we have kept a target lag of 1 hour, after every 1 hour, the Cortex search will check if there is a new data. If there is a new data, it will try to index that data and it will start serving that particular data to the user. The other way of creating a Snowflake Cortex search is with the help of this particular UI. I'll show you one disadvantage of creating a Cortex search with this particular UI. Let me select the database Cortex SVC. This is my Cortex search service. Creating a search on Airbnb. The next thing is I need to select a search column. In this particular search column, with the help of the SQL, we were able to select summary, description, etc. But if you check here, right, you can select only any one type of a column if you are creating with the help of the UI. So this is a particularly a disadvantage when you create with the help of UI. Once you check this search column, you need to select what are the attributes or what are the filters for you. So our filters were right room type, if you remember, and the other filter was amenities. And the second thing is you need to select some of the columns which you want to show to your user whenever a user search for a query. So the price and cancellation policy will also be indexed so that whenever a query is being executed, these can also be fetched in the results. So I'll click on the next. So my target lag is 1 hour. Default embedding is 1.5. You can change anything. The output dimensions will be around 768 and the particular warehouse will be Cortex Search warehouse. So let's create this particular service. So if you see here, your searchable column is the listing text and your attribute columns are room type and amenities, whereas price and cancellation policy are also been indexed so that it can be retrieved very fast. So once your Cortex search service is created, you can query this with the help of Python API or a REST API, or you can query this with the help of SQL. You need to use this SQL function only for validation and testing. SQL is having very high latency. So for example, I'll search a query which place mentioned being is positioned on the Jordan area. So, and my columns are, which are the columns I need to fetch. I need the listing text. I also need the price and the amenities. And my filters are, since it's an array, I'm keeping a contains filters. I want an amenity like TV and I just need three top results. So once I execute this query, I got a result set. If I copy this result set, let us see what exactly is there in the this particular result. So I got around 3 results. So if you see here, this is my vector search score. This is the cosine similarity. It's like 0.45 similar. And this is my keyword search. And it is shows us like how similar this particular query was. It's around 0.05. And I also asked for the amenities and price and the listing text. So if you see here, my amenities, I said TV should be there. So it checked for the amenities, which is also having the TV. And this is the listing, which exactly is near the Jordan area. If you see here, we are at the heart of the Jordan area. So it is able to fetch your data, which is very near to your query search. And the price for this is around 322. You can also add some of the other columns which you want to index, for example the Airbnb IDs or the Airbnb owners phone number, so that you can provide that to your customers. So the next thing is custom scoring. For example, if you have an Airbnb and you have a feedback from your users, for example likes will be there, clicks will be there, comments will be there, you want to give a higher score to the likes which are there. So for the dislikes you want to decrease the score, so you can provide a numeric boost to that particular like column. The other way is, or if you have a recent Airbnb, so with the help of the timestamp, so you can say like when is the date created of this particular Airbnb. So the latest Airbnbs are fetched in the particular results with the help of this particular time decays. Whatever the score you are providing, that score won't affect your vector similarity score and the text score. This re-ranker is the one which arranges that particular vector search and the text search in an order. So by default, this will be enabled even if you use the Cortex SQL. The other thing we need to look into is the cost. There are five types of cost associated with this. One is your virtual warehouse cost. This cost is nothing but the cost indulged in indexing or the cost indexed. And the second cost is the embedding text cost. You need to embed your data into a vector dimension, that particular cost. The third cost is the serving compute. Whatever the index data, that index data should be stored in some type of a cache or some type of a storage so that you can utilize as soon as possible. And the other fourth type of a cost is the storage cost. For example, your table will be converted into such a format in such a data structure format so that it will be very fast on querying that particular data set. And the fifth type of the cost is the cloud service layer cost. To trigger this particular thing, you need a layer which is already switched on. So this particular cost is been covered with the help of cloud service layer. So if you see here, right, it's the cloud cost and the compute cost is been consumed by this Cortex search warehouse. This is the AI service cost. So as we are end to this session, I have two particular questions. One question is, for example, this is my query which I can directly use the embed text to embed my particular string or my particular data and get a vector embedding. So why do you use Cortex search service instead of embed text? And my second question is, for example, if there is any change in the base data, so do you need to create a Cortex search service again? So this is my question. Just think about it and comment it. If you like this video, please like, share